Okay. James, do you see my screen?
Yes, I certainly do, sir. I see Varnish Software.
Okay, excellent. Okay, guys. So let's start. Welcome to today's webinar. With me today is James Governor. He's an analyst Redmonk. Would you mind just sort of giving us a 30-second introduction to yourself, James?
Yeah, certainly. So Redmonk is an analyst company, but don't hold that against us. We do things a little bit differently than the Gartners and Forresters in that we are more interested in developers and practitioners and adoption than we are purchasing. We think in the age of the cloud and open source, purchasing is increasingly decoupled from and often becomes subsequent to technology decisions made by practitioners, developers notably. So our analysis is predicated on the decisions that developers make rather than legal or purchasing or some CIO that last touched a terminal 30 years ago. So yeah. we're sort of analysts, but we spend our time looking at what's happening at GitHub and Stack Overflow rather than high-level sort of architecture diagrams.
Okay, great, thank you. And on the right side there, that's me. My name is Buer. I work as CTO in Varnish Software, a company I founded 4 years ago. Yeah, and the topic for today is slow performance will kill your API strategy. So we'll just sort of ease into it by sort of talking just a tiny bit about what sort of web-based API is. I mean, I think most of you probably know this, but just good to have it covered so that we know we're on the same page. I mean, basically, we're talking about invoking a remote procedure at some other server, typically in order to get some data or to report some data to another server. And this used to happen through these weird proprietary protocols, but today most of it actually happens using HTTP. That's sort of the modern ways it happens. Yeah. So sort of that leads us to sort of how APIs are used today. And of course, I mean, the driving sort of force behind API adoption today is probably apps. I mean, I think probably 95% of the apps on my phone, they are typically backed by some API. So when I read my email today, it used to be delivered through IMAP. Today, all of it is actually delivered to my phone using various HTTP based API calls. So apps has, of course, probably been sort of the strongest driver for sort of adoption of web-based APIs for the last 5 or 10 years. Another thing we see is that web pages aren't web pages anymore. They used to be sort of the old way of sort of building web pages. You would sort of have your server render some HTML, you would ship it off to the client, and then the client would basically render it. You might have noticed, like, I think it was a couple of years back, Facebook stopped doing that. They started basically shipping off a JavaScript application, and then that JavaScript application started querying the Facebook APIs and sort of filling in those, fetching the data through APIs instead of actually the whole thing coming pre-rendered. And I think like most websites that are actually being built today are probably sort of built on that architecture, or at least maybe probably a hybrid. I don't know. James, do you have any sort of idea on what the sort of split there is? Do you find people are still doing sort of?
Yeah, I mean, certainly the more modern approach is as you've described, and for organizations that are expecting any kind of scale, that's certainly the sort of approaches that we're seeing. So, an exact number on it, I think, is difficult. But increasingly, the sites that are gaining traffic, and frankly, their orders of magnitude above those of other sites because of the user experience they're driving, are using the sorts of foundation that you're describing.
Yeah. And of course, I mean, we can't really be talking about APIs today without referencing the sort of buzzword of the year, which is the whole Internet of Things. I mean, the promise of the Internet of Things is that we all get our stuff connected somehow, and that those things will need to talk to the rest of the internet in some way, and of course,
This stuff is definitely real, Per.
Yeah.
I think that we've been covering IoT from a hacker perspective now for probably 3 or 4 years. But the conversations we're having, I was talking to Bosch, the German power tools manufacturer and industrial conglomerate. And they're going so far as it turns out that their customers have teams to manage tightening of screws and bolts. So the customer will have a team of 10 people whose job it is to manage the tightening of screws and bolts into things, which seems a little bit ridiculous, but of course I fly in airplanes a fair bit, and I want to make sure
Yes.
that the bolts are tight. So it's sort of non-optional, and they are currently, literally every single screwing and bolting operation, they want a time series for that, and then they want to correlate that with the three-dimensional models in their Dassault CAD/CAM systems. So we've sort of gone from hacking to this becoming what really does look like an industrial reality.
Yeah, but I mean, its reach is far outside of industry. I mean, when people talk about IoT, I sort of tend to think of that as something that's in the future. I don't know why I tend to think that way, but I mean, I bought a Philips Hue kit, I think a year ago, where my light bulbs are now connected to the internet, and I can control them through my smartphone. Which, by the way, I'm not sure if it's a good idea. It's incredibly cumbersome to sort of to put out the lamp next to my bed by using my phone. I used to have a switch. Now I need to get my smartphone and actually turn it out, and it's like a horrible UX. But I mean, there's I think that, so I think like we're stumbling a bit now. But I mean, quite a few of us already have sort of connected power meters and things like that. Do you draw sort of somehow a distinction between what these things are? I mean, when we talk about Internet of Things, do we talk about small things, or would you consider like a car? Is that a thing?
Yeah, I think the cars are certainly things. I think that was, as was said recently, perhaps the key moment in recent industrial history was recently when Tesla shipped an update to allow cars to become driverless as code. And that's a sort of a staggering moment in terms of the industrial society that we live in. I think you're right to talk about phones as well. I mean, phones are incredible in terms of the sensors that they natively have, but obviously there are new sensors coming on board. And we can think whether it's measuring, we've talked about fitness, but measuring things like blood sugar levels, easy sensors that can plug into phones for that. I heard a very nice example recently, which sounds a bit maybe cheesy, but I can really understand it, which is it's just something that's designed to listen to your heartbeat and put that next to your partner when they're at home and you're traveling, which is interesting. I think that one of the things about this IoT thing is we're caught off on, it's about the machines, but it's not. It's about the people, and it's about better experiences. And the phone is just an incredible context, and the kinds of architectures that we're using for building mobile apps are the same kinds of architectures that we're using for building Internet of Things apps. So we look at the programming languages. It's interesting. Node.js is going absolutely gangbusters in things and devices. If people on the call have not checked out something called the TESSEL, TESSEL, from a company called Technical Humans, you really should. It's very beautiful because it just makes it very, very easy You know, it's all JavaScript, and you literally just say things like take photo, and of course it takes a photo. So I think this stuff is getting easier and more compelling, and the web architectures are increasingly what's taking over. I used to talk about how M2M, you know, that space, and it was all the world of people programming everything in C and then spending 20 years in darkened rooms arguing about security standards so that we would never ever have any Internet of Things. Today, it's more of a hacker mentality, move fast, break things. And yes, we need security, don't get me wrong. I don't want someone to make my milk go sour in the fridge or to make my car crash. But on the other hand, we need to make some progress. And as the web has shown, it's a tremendous engine for progress, and it's where the programmers are. You know, when you look around, you try and find a C programmer, good luck. You try and find a JavaScript programmer, and it's a lot easier.
Yeah, I mean, from us, I mean, we're not into making cars or fridges or sort of any of these devices. I mean, our perspective on this is that the amount of data out there that will be reported sort of into various sort of cloud-based solutions will increase dramatically. I mean, there are, I don't know, 35 million fridges in the UK. If any of them are sort of to report any data, let's say like once an hour or something, that sort of quickly turns into something, I don't know, 5,000 requests per second just from data from those fridges, which of course then needs to be handled. And of course that's a scalability issue. And that's sort of our perspective coming into this. Of course, there's also sort of, when talking about sort of web-based APIs, there's also the sort of traditional where it all basically came from. I think, at least that's my perception on sort of where web-based APIs came from. They came from sort of server-to-server communications. There were basically one application needed to talk to another application, needed to have something done. And then we had things like SOAP, which was, and these were of course all horribly slow, and they were very cumbersome. And they were like XML was all around, and it was sort of all a big mess. But that's still, I would say, is a significant use case for web-based APIs. And of course, I mean, the whole all the interest around specifically microservices, of course, is sort of dramatically increasing the number of web-based API calls. So the microservice architecture, one single API call from your phone might sort of result in 50 API calls on the back end in order to service that one single API. And of course, that adds quite a bit of overhead, and of course you need to manage all that.
That's exactly right, Per. Just before you move on, I mean, the microservice implication is exactly right in terms of N-way calls. And yes, absolutely from the mobile devices, but this has been an ongoing trend. You know, you think of something like when you go to Expedia or any of the travel services, you know, you'll think you're just doing a search, but what you're actually doing is triggering a fanning out of a lot of API service calls to a lot of backends. IBM, it's kind of funny, you know, they're all talking about mobile first all the time. But their customers were coming and saying, look, you know, this mobile is killing the mainframe. And they had two options. One is to say tough, and the other was actually they've had to lower the cost. So now when transactions are triggered from these mobile applications that are doing the searches for them, they're not actually charging the customer for the MIPS-based capacity because it's never just one search. It's tens, 50s, possibly hundreds of API calls to a number of different backend systems. And we're seeing that now within microservices as well, within the organization and without.
Absolutely. So, I mean, and this is something that sort of is growing dramatically. I mean, the whole, also this is just taken from Google Trends, where you see sort of the interest of it. And you can see sort of, I mean, I wouldn't exactly call it a hockey stick, sort of, but I mean, there's steadily building interest in sort of APIs. And of course, I mean, and they are, of course, so I mean, APIs are obviously important. I think like all of the participants here are sort of well aware of it. There are some sort of interesting sort of factoids here. I think that it was EMA, which is some analyst house. I can't remember what it stands for. Something enterprise, something. And they're talking about API growth with their customers of between 10 and 20% per month, and that's per month, which is I would say a really rapid growth when it comes to sort of the traffic on their APIs. And that's sort of also a sort of background factoid. We've done some sort of events around Europe, and for the last 3 events, I think we've been handing out the survey, and we did survey, I think, of roughly 100 participants now. And this is with regards to API management, where we'll be going there in a few minutes. And that, I think it was 74% of the respondents, they use some sort of homegrown solutions for API management, which is interesting. I'll get back to why I think that's an interesting figure. So, and then sort of we have this promise of the web was that we'll be turned into this global village, and I think that to some extent that's happening quite a lot more than I think most of us actually foresaw. We were just talking to James just last week, and we were discussing sort of how weird it is that sort of Halloween has sort of turned into this European phenomenon. Like, my kids have been dressing up for Halloween for 4 years now, I think. Or like 10 years ago, Halloween was not a thing in I think neither in Norway or in the UK, but now it is. And I think in the last couple of years we see phenomenons like Black Friday sales, and sort of other sort of global cultural sort of phenomenons. We could have this sort of standing bet on how many years it'll take us to before we have the Thanksgiving celebrations in Europe. And I mean,
it means that we can't avoid Donald Trump.
No, definitely not. I mean, looking at the U.S. presidential elections, that's probably going to be our future, or it's probably going to be horrible. But I mean, why is this? How does this relate to APIs and to sort of traffic levels in general? And that's because, like, the world is turning global, and these extreme spikes that we have will become more and more extreme as time goes by. I think like products, they don't necessarily just blow up in a single country anymore. They tend to blow up globally. And when they grow up, of course, traffic spikes through the roof. And that's basically been the case on the web for the last 5 years. But we see that that's something that's definitely coming into APIs as well, as we see sort of API bear the brunt of the work when regards to pushing out information. I mean, as I said, we don't necessarily deliver HTML anymore. We deliver JavaScript applications, and then we have APIs that are sort of filling that with content. So I thought, James, I'll just leave the word to you for a couple of slides. I think.
Yes. So I think that the key point is, as you begin to look at this, what we used to think was the burst, the top level. Oh, this is something that is happening occasionally, that we have this extreme spike that we need to deal with. A good example, taxes. Clearly, when you pay your taxes, your tax authority has to deal with everything on the last day, because nobody processes their taxes beforehand. But we think about this in any areas, retail. We've spoken about Black Friday and so on. Certainly, the media. Okay, we need Amazon Web Services so that we can be elastic. This notion of elastic scale has been very much the way that people have been thinking. But increasingly, it's not so much the exception as the rule. So, Per, if you want to move on.
Sure.
So we've spoken about this API economy, and I know I said I was an industry analyst that was about developers, and yet here I'm going to give you some big made-up number. But I think it's interesting. So IBM has just begun to make a very big noise around the API economy, and they're saying that by 2018 it's going to be a $2.2 trillion market. Huge numbers. I think that an awful lot of digital transformation gets counted in that. It's certainly part of how IBM is viewing the world. But it's like, yeah, okay, that's somewhat abstract.
Do you have an idea of sort of, if you could sort of break that down a bit? I mean, like what is that like figure? What does IBM put in it?
Yeah, I mean, I think that there's an awful lot in there because, I think the API first is mobile first, is social first, is, all of these transformations are driven by APIs and the cloud. So I'm pretty sure IBM is factoring in a lot of what we just consider cloud workloads, digital transformation workloads. I don't have the exact numbers. I don't think they do either, but pretty clearly, what we've seen is that organizations do one thing, and it leads on to a number of other changes in the organization. So mobile has been a huge part of this. So if you even just think about how you develop applications, what we're seeing, I think a good example for me in terms of scale, and perhaps this is something for Varnish to think about as an opportunity. Marks and Spencer's is a very famous UK retailer, and Marks and Spencer's, what they do is they sell two things. They sell three things: underpants, bras, and sandwiches. And they're very good at selling sandwiches. And as long as people are buying their bras and underpants and sandwiches from Marks and Spencer's, they do very well. They have a very traditional IT infrastructure. And it was all mainframe based, and it was very difficult to make any change and make things happen. So when they wanted to do mobile, they went out and they actually hired a lot of the young designers and developers from some of the top agencies in London and brought them in-house. So they've got this mobile team that is agile, only uses the cloud, that is very much API first in terms of their approaches. And it was very interesting to me. I mean, I meet the guy that's in charge of this, and I was using phrases like developer joy, optimizing for developer joy, kind of the Etsy, GitHub kind of way of thinking. And he came back and he's saying, yeah, when I was reading the Etsy blog and so on, and I think what was really interesting then was the new nature of scale and the tolerance actually. Things can kind of break as long as you can turn around and fix them again. So he was talking about the fact that when they first rolled out some mobile applications and they did fall over, and everyone on the team was high-fiving and cheering and going, yeah, woo, and really excited. And there's one IT guy in the back of the room looking really confused and a little bit grumpy. And then he says, what's going on? I don't understand your team. Why are they celebrating failure? And the guy turned around and said, well, this isn't failure. This is user demand. We got so much demand that the system fell over. Now, obviously, it would be good to remediate that. But the fact that there was a group there that was doing all of these new things, and they were going, okay, now we can roll out a new rev of the application that won't crash. These teams are doing stuff that all comes together. You can't do mobile development without thinking about Agile, without thinking about APIs, without third-party API calls. So I think this number from IBM is just saying, look at the change. And in the past few weeks, GE stood up at Amazon reInvent, and they said, we're going to have 70% of our workloads on cloud within 3 years. And you think, okay, that's GE. They're being a little bit rhetorical, but clearly it's an industry bellwether. Then last week, Coca-Cola stands up and says we're going to have 65 to 75% of our workloads in the cloud within 3 years. And at that point, something very, very significant is happening. And clearly, the cloud phenomenon is an API phenomenon. And I think that's what IBM is describing. I think what's really significant about IBM from an enterprise perspective is, look, when IBM says it's time for APIs, then their customers, and that's pretty much all enterprises, say, oh, IBM says the time is now. So I think it's a bellwether, and certainly I would expect some pull-through, and I'd be interested to hear from people on this webinar, what they're seeing, but certainly their bosses, the people that Redmonk isn't always talking to, are seeing these sorts of noises and thinking, okay, that we need to play. So Per, if you'd like to
of course.
keep going. And this, I think the slide kind of speaks for itself. I think what's interesting, you mentioned that stat from the Enterprise Management Associates of 10% growth per month amongst their client base. Their client base is pretty traditional. I think what's interesting to me is that not the 10% across 100 organizations, but there's probably 2 or 1 organization that is seeing 90% of that growth.
Yeah,
because
absolutely.
These growth paths are certainly not linear. They are exponential. When growth kicks in today and people jump on board, we see huge change. And the perils of success that I spoke about, whether it's Marks and Spencers or otherwise, succeeding is scary because of these viral effects and the fact that yes, it can be global. It's not just a local phenomenon. Americans asking, what's a cheeky Nando's? Now, maybe people around the world wondered, what is a cheeky Nando's? Nando's is a chicken shop here in the UK, and it's a silly phrase, but it trends on Twitter, and then everyone's asking what it is. So I think it's the 10% is interesting, but it's the fact that actually success is likely to mean 1,000, 2,000% growth, and that's the key. Wow, I was about to go talking about global warming. I better not move down that path.
No.
If we can carry on. Yeah, and so I think this throughput issue for me was really clear when looking at Twitter, because Twitter was a spiky thing, memes popping up and then dying away. But the 2012 election, and I know that we can expect the 2016 election to be even more the case for driving back-end workloads, was that instead of it being something that was temporary, it was something that it became permanent for hours on end of API calls. And if you look at Twitter is one example, and it is going to be seeing a ton of traffic. We'll see under the auspices of the CEO Jack whether developers actually go back to targeting Twitter or continue to think it's not on their side. But clearly media businesses are taking advantage of those APIs. And then if we think about media businesses themselves and classic examples, the Guardian in the UK, perhaps the New York Times in the US, they're seeing extreme workloads during these times, and they're global workloads. I think it's that. This is the big change.
Yeah, and I think I've talked to one of these organizations, a major in the US news organization, and I think their predictions for next year's presidential elections are, with regards to API calls, are approximately 100,000 API calls per second. Which that's for most of us, of course, that's insane, and that doesn't sort of relate to us at all. But I mean, even like we have more sort of traditional brick and mortar sort of businesses that sort of, and I think like one of the retailers that we're talking to, they are primarily a physical retailer, and they expect somewhere between 15 to 17,000 API calls on the API rig during this Black Friday here. And of course, I mean, and they sell stuff like hammers and nails and stuff. So they're not primarily sort of web first, but still, I mean, it's touching everyone.
And this sort of notion of referrals, and this is kind of amazing. I think Pinterest is a really interesting network in terms of what they're driving, because they do really drive behaviors by people. We've seen. I don't know if you remember the service StumbleUpon, but we talk about StumbleUpon waves, when again it's that sort of quite bursty workloads, but now the burst looks more ongoing. But Pinterest is driving incredible traffic, and a lot of that is driving shopping behaviors and so on, because you see something interesting and then you go and buy something.
Of course.
And so for a site like that, they've come out of effectively nowhere, a completely new architecture of participation, It's quite nice because it's quite gender neutral. In fact, possibly skewed to women. I just think that it's something that is so new compared to these other services is driving that much traffic is again a mark of how things are changing.
Yeah.
And so if we move on. I think this is just to me, and in terms of Pair and how you deliver an architecture that can support extreme scale, one of the things we've seen is that these web companies, they start out saying that Java sucks. Everybody, when they set up a new web company, oh, Java sucks, we're a PHP shop. Oh, Java sucks, we're going to build in Ruby because Ruby is awesome. And then they find out, actually, oh, shit, this doesn't work. Twitter realized, and in fact, the only reason they could do the presidential election without falling over was because running on a JVM. Netflix has been a Java application. Now, of course, they modernized the Java application. It is microservice based. They've got some really good ideas about how to build architectures that don't fall over, architecting for resilience. But all of these companies, Facebook is a great example because they definitely, when they began, oh, Java's no good, Java's no good, Java's no good. Oh, wow, we can't even analyze our own messages. Oh, okay, how can we do that? We'll build a key value store. Oh, no, it's not scalable enough. Okay, we'll use Hadoop. And now they explicitly say, actually, look, it's not just Hadoop, but the surrounding infrastructure services. Giraffe is a graph database built in Java. So they're making choices that are about this scale. So the JVM is going to be part of the story, but of course there are these other layers as well because they don't replace everything.
I've heard this you talking about this before, and I mean the lesson I think that these companies make is, of course, I mean you start out by sort of picking your components based on I think features is what you want. I mean Twitter was attracted to Ruby on Rails because they could prototype and sort of ship things within hours, and of course that was great, but that only sort of gets you this far. And at some point, you need to sort of have something that's robust and performant and manageable. And that's, of course, a shift for a lot of. And I think for Twitter, it was quite a painful shift because basically they had to rewrite everything, of course, while operating, of course. And I think that's an interesting or an observation where these companies have made that learned that lesson the hard way, and that I'll come back to that in a few moments.
And so, I think that this is an interesting example. In a sense, they say, oh no, we're not going to do this. So Asda is the UK version of Walmart. They're owned by Walmart. And they actually said, look, we're not going to do Black Friday because they say shopper fatigue. It's really not shopper fatigue. It's that last year they had riots and violence in their shops because people were so buying into Black Friday. So we really have turned into, oh wow, I was about to say we really have turned into Americans. That's maybe a bit racist. We've turned into shoppers that really buy into this stuff.
Consumers, I think, is the neutral word.
Yeah, we're aggressive consumers. And so Asda, I think, is saying this to, oh no, we're not going to do Black Friday. This is them saying we can't handle the workload. So they invented this, Black Friday, but now they're saying, oh my God, at least in stores, it's dangerous. So we better calm it down a bit this year. So I think that I would be very surprised, and you only need to look on Black Friday is already trending and will probably be trending again until after Black Friday. So it's this, this is the new reality that they're so good at getting us all shopping that now we need new architectures to deal with that.
Great. Okay, so I'll spend some time sort of trying to get us back to sort of the original topic here, sort of scaling APIs. And to what we are talking about is a lot about the actual infrastructure. And our sort of contribution to this has sort of been an API manager. Now, sort of what an API manager is. So, I mean, if you have a sort of set of APIs, so these are just sort of 4 random names are made up, and then you have sort of a bunch of consumers that sort of are consuming these APIs, and they start doing API calls. And at some point, the moment you have if you have one API, that's not probably the time where this happens, but at some point you have these need for these common functions that need to function all across your APIs. And of course, depending, of course, how crazy your organization is. So, I mean, if it's a microservice organization, you might have your APIs might be actually delivered on 5 different platforms, and then you want to add some common functionality to all your APIs. That becomes, of course, a significant pain in the butt. So this is where sort of an API manager is typically introduced into the stack. So basically, I mean, what it does is that it adds sort of security, and security here mostly means authentication and authorization, so access control basically. So it adds access control to all your APIs, and of course it makes a lot of sense to have that as sort of a common function across all the APIs, because if you have 50 different APIs, you don't really want all of them to sort of connect them and re-implement the same authentication scheme in all of them. Or at least if you're changing the authentication scheme, you're probably very happy to avoid that. And then, of course, there's throttling, of course, which is basically to avoiding abuse or detecting and avoiding abusive behavior. There's routing, there's metrics, there's sort of all of these different things that you want in this specific layer. So that means that you end up with a very sort of simple architecture, or at least from my perspective, it sort of looks simple because I sort of simplify the bits that I don't care about. And that's that you have this sort of API manager or an API gateway, it's also commonly referred to it. You have some sort of application and you have some sort of database. And of course, the interesting bit here, if you don't scale, if the gateway doesn't scale, you're sort of dead in the water. I mean, one thing is that if the database doesn't sort of keep up with demand, that's one thing. And of course, you need to make sure that it does. But sort of on the top of the list is probably the gateway, because if the gateway doesn't keep up, then of course, none of the other matters, of course. And I'm going to tell you a bit of a story, sort of how we got into API management. Because it started sort of a few years ago. So we started doing, I think it was 4 years ago now, or 3 years ago, we started doing paid content in Varnish. So basically that meant that we found, we devised a way to configure, to make authentication and authorization happening inside Varnish. The point of that was, of course, that for a media website, you want to deliver cache hits and have them authenticated and authorized, because some organizations thought it was a good idea to only deliver some pieces of content to paying users. And they were basically, their alternative was to sort of to have those users bypass the caching layer and to have that logic in the application servers. And if the application servers were to do that, of course, that would slow down page delivery, and then the paying users would have a worse user experience than the other users, and of course that's bad. So we made authentication and authorization happen within Varnish. Then at some point we did that again but this time for a little company that had one API. And we basically took Varnish and we took and implemented basically the same logic, except that it was database driven and sort of and it sort of worked kind of well. I think we wrote a couple of blog posts about it. And then at some point we had one of our customers, which is a big American media conglomerate. We had them turn to us and they were asking, because they have this API, very API intensive application. It's some sort of game. It's kind of big in the US, and they were running a product from what was at the time a company called Mashery, which is one of the sort of which basically is the company who sort of invented this part of the business. It's a kind of it's an interesting product. It's sort of top right on the Gartner Magic Quadrant, but they couldn't get it to perform. So they were basically, it would peak out at approximately 200 requests per second per server, and their performance requirements were around 10 to 15,000 API calls per second. So they were basically had to scale up that API management layer to something like 50 to 75 servers. Of course, 50 to 75 servers, even for a big organization, is quite a bit, and it's the software itself isn't cheap, and of course the infrastructure isn't cheap. They came to us and asked us if we could we do authentication authorization inside of Varnish, and I think also then throttling, because they needed to keep abuse out. And so we basically did that as a sort of bespoke development. And we delivered it, and they installed it on, I think, on EC2. And I think we got around between 10 and 12,000 API calls per second per server. And so it's actually was quite a success. So instead of 50 to 75 servers, they were able to get away with it, with running. I think they ended up running a total of 6 servers, just to have some headroom. And as we sort of moved on, and we talked to other people about this, and we saw this basically the same story happen again and again, that there were quite a few API gateways that were not built for performance, and that these organizations were then sort of forced basically out of those solutions as soon as their API started to scale. So as soon as the sort of marketing got any traction with their new app or whatnot, they would have to basically re-architect and remove the management layer and implement the management functionality directly into their APIs, because that management layer didn't scale. And at that point, we basically took the decision to come up with the API engine. So that's basically how the product came about. And yeah, so we had a 2.0 release. I think it's now a month ago or something, 4 weeks ago, where we basically so we do authentication, authorization, throttling, metering, and we do approximately, we're at a performance level now where we are delivering 23,000 API calls per second. That's on a 3-node EC2 cluster. I think they're with extra large instances or something, and it sort of scales horizontally well beyond that. The pilot, one of the partners that we're working on, is working on an installation of the performance requirement of 100,000 API calls per second. And so and then we have added sort of role-based management and sort of a graphical UI to it, and it's all fully API driven. And of course, our goal here is to try to make a bit of try to change what people talk about when they talk about these APIs, and specifically when they talk about the API management bits. Because as far as what we see is that nobody talks about performance and API management. I mean, there's some talk about APIs and performance in itself, but API managers are currently being exempt from sort of having their performance measured. And I have an idea of why that's happening, but I think it's really dumb, because I think it's as crucial for these API managers to have performance as it is for databases. And of course, and I think so why is it like this? And I think that to some extent it has to do with where the API management industry comes from. So I mean, and here are the industry analysts, because API management is basically something that's come out of sort of traditional enterprise. Basically, was the data exchange between the servers. This was because the whole industry was based long before we had things such as Twitter and the sort of web native companies came about. It started back in the day when basically was the SOAP protocol was basically the way that you would do it, and you had two servers and they were more or less doing some sort of batch processing, and one would talk to another and with the SOAP call and ask, I don't know what it would ask, but it would ask some question, and it would answer it, and then that those systems grew, and you needed some sort of management layer that was fulfilling a bunch of functionality there, and then they basically, that's how the product came about. And of course, what the analyst did, of course, was to do their job in all of this, and what they do. And this is sort of where we're slightly at edge with some of the analysts that are operating here, because if you read the analyst reports about API management from, let's say, if you call probably Gartner and Forrester, I think those are the two biggest industry analysts out there. They don't mention performance at all. The word performance does not show up in any of their analysis of sort of that space. That's actually really curious. And of course, we're sort of way past the days where I mean, like back in the 90s, you would have these reports where some guy would sit and install 5 different pieces of software and then sort of do an evaluation. And then sort of come up with a report. And I think like back then, performance was probably sort of mentioned as relevant. But since then, the world has become such an extremely complex place, and these pieces of software are so extremely complex that for an analyst to do, like, actually try out, for instance, 5 different API managers and actually write a report about that, like based on first-hand experience, is probably impossible. It will probably take a year to do that. And of course, you can't really afford to do that, because if you do that in that year, of course, everything will have been moved on. So what we're stuck with today is the world where analysts basically are talking to CIOs, and CIOs are talking to the project managers, and the project managers are talking to the engineers, and the engineers are actually doing the work. So there's so many filters between the people that are actually touching the software and what sort of ends up in an analyst report, that the focus of that reporting, of that analysis, is not necessarily directly connected to how the software actually behaves, what it does. And of course, and we've seen this firsthand, because we've had customers who have followed analyst advice, and sort of the big American media conglomerate that we talked about earlier. I mean, the reason they had this piece of software installed was because of industry analysts, because they picked the product who was up in the top right corner of the Gartner Magic Quadrant. And nobody at Gartner mentioned the fact that this software doesn't actually deliver the baseline performance that you need in order to have this actually work in the real world with the workloads that you have. And so,
look, one thing, and whilst I'm delighted to hear what you've got to say about other analyst firms, in terms of the new world I described, it's really simple. Can I look at this stuff, and is there any source code that I can get a view of what it is, or are these features that are enterprise features for enterprise people built on proprietary platforms? And I think it's that accessibility that is incredibly important, and that's the practitioners are choosing software to enable them that is accessible, and I think that's really important. That you're right about the who's driving the requirements, but it's also about who's driving accessibility, and I don't need to. I think you understand something about open source and developer-led adoption, right?
Yeah. So I mean, when we launched this product, we have a very good, long, hard think about whether or not this should be open source. And to be completely frank, we already maintain a significant amount of open source, and we ended up on the side of not doing it this time. Basically, I mean, and there's two reasons for that. And one, of course, is that we need to pay our bills and all that, but you heard that before. And the other one is that if we were to add another significant open source project to our company, the effort would basically bog us down. So we've not open sourced this. The engine, of course, that it runs on, it runs basically the API engine is our engine that runs within Varnish. And that's, of course, that's the secret sauce for our performance, is that since it leverages Varnish for HTTP processing, the whole thing goes fast because Varnish is fast. So we basically just sort of spent the last 10 years investing in that platform, and now we can sort of, to some extent, reap the rewards by writing applications within it and then having them perform spectacularly well. So, of course, but it's sort of, so I mean, I wish we could sort of give away all the software, of course, but yeah, then again, we don't, because we don't have the bandwidth to do that, at least not currently.
But the engine is accessible. It's something that people can understand, and I think that's one of the factors I think that is continues to be significant in this industry.
Yeah, absolutely. I mean, we do deliver it with full source code once you sort of pay for it, of course. But so you get parts of it. You get and it's sort of I mentioned this to you before. Sort of we did this sort of experiment when we set up the product teams to manage this. Is that we decided to have DevOps people be the core architect and developers of the project, which brought their own agenda into the product development. And these are all people that have spent at least 10 years of their life being woken up in the middle of the night because some schmuck wrote some piece of software that crashed at 2 a.m. Of course, that meant that they have slightly different priorities than sort of the developer which hasn't sort of lived under that kind of pressure.
By the way, so we've been rambling on. Per, did you want to get questions from people that have been on the call, or? Absolutely.
So this is the sort of Q&A session. There's come up one question has come up so far, and that's, will there be a recording of this session? And the answer is yes. I think you'll have you'll get a mail, by the end of the week or next week, with sort of a link to a video. So, are there any other questions? So if you can use the sort of questions tab there on your webinar thingy and ask the questions if you have any. In the meantime, you could probably do the question that I've seen you alluded to on Twitter, James.
Oh, there seems to be more than one question. Well, sorry, if you're going to set me up, I'm now. Hang on a second. We spoke about this the other day, didn't we? I'm now forgetting my own setup because I've been paying too much attention to Twitter. Treat it as a question from the audience, Per. That's the thing to do at this point.
Oh, yeah, okay. So you asked me about MQTT the other day.
Sorry, how pathetic of me. Yeah, it's that. We've spoken about the Internet of Things. And is it all going to be HTTP when there are other protocols? And
yes,
what are you going to do to address that?
and that's really interesting because actually I've been sort of living this. I wasn't really very familiar with MQTT, so I spent sort of the last couple of days reading about it. And it's actually, so MQTT, for those who don't know, it's a sort of this binary protocol that's very, very lightweight. It's sort of built for embedded M2M or the Internet of small things. And compared to HTTP, it's very light. I mean, binary framing and everything that makes it possible to implement this in low power hardware and such. And the interesting question is, who will drive the sort of Internet of Things? Because the Internet of Things will basically do. So why do you put like a processor and operating system in your fridge? Is it so that the fridge can report its temperature back to the manufacturer or the service company, and some guy can show up at your door fixing your fridge the moment it starts behaving weirdly? Or do you want the fridge to talk to Walmart? Because I think that question basically will drive if HTTP will win or if MQTT will win. Because if we're doing the Internet of Things because of the devices, in order to sort of support the devices, MQTT is definitely the preferred way to go. It's a super lightweight protocol. But if you want the fridge to automatically order milk at Walmart, that fridge have to deal with Walmart's APIs. And Walmart's APIs, of course, will become HTTP based. And so I think, like, to some extent, I think we'll probably see both, of course. But my idea, and of course I'm hugely biased here, is of course I think HTTP will probably be the dominant one out of the two, because I think like most of the gain with the Internet of Things will mean that these little things can actually interact with the sort of established web and established APIs that are on the web today. So what do you think, James? Does that make sense to you?
Yes, it does. It's going to be a both world. There is absolutely no doubt that HTTP is going to be a big part of the IoT world. No question whatsoever. However, are there going to be some other interesting things around messaging and so on? Absolutely. So, new buffering architectures, all sorts of new stuff. But no, I mean, the architectural style that we've developed over the last few years isn't going away anytime soon.
Yeah. So I mean, like if I look at my home, the things I have there, the light bulbs, they talk Z-Wave or something, some proprietary protocol, and they talk to a little box, and like, so they use this lightweight little protocol inside the house, and then they talk HTTP back to Philips, and then Philips talks HTTP back to if this then that. So like currently sort of most of the things that are connected are HTTP based. If that seems to be the only question that we got. So unless somebody pops up a question really, really fast, I think we are probably will call it a day. We spent our hour and then some. So I thank you all for attending. Thank you especially to you, James, for taking the time. It's been a pleasure to talk to you as always.
Great. Well, likewise. And if anyone has any questions, I'm more than happy to help after the fact. And I will look forward to talking further. I think this is a very interesting space to be tackling, especially because those other companies that you mentioned have been acquired by other people that don't know how to manage stuff. So
yeah, we'll see.
Yeah, I mean, there's software that has a growth curve, and then software that's got maintenance.